Today our topic is bisection method, that is also known as bracketing method or the Bolzano method. Particularly, bisection method is used to find the root of any algebraic and transcendental equation. What is Bolzano's theorem? That bisection method is based on Bolzano's theorem. Bolzano's theorem say if a continuous function defined on an interval is sometimes positive and sometimes negative, it must be 0 at some point. And that is also used to find out the root of any equation. Bolzano on 1817 proved the theorem. As this method is always completely based on this theorem, after the name it is known as also Bolzano method. Now why that method is known as bisection method or bracketing method, that will be discussed now. Bisection, bi means particularly 2 and section means division. So particularly this method is used bisection of the range found, and after if and every range we are just converging to the point. That also be just discussed now. Let us consider the equation, and the equation is at that moment x to the power 4 plus 2x square minus x minus 1 is equal to 0. As we see, that equation has the maximum power of the variable x as 4, so we can say that algebraic equation has 4 roots. In this problem, we are just finding a positive root of that particular equation. Now, according to Bolzano, let us consider that equation as fx. Okay. Now we are finding one positive real root. So we are starting from the value of x as 0 from here. Okay. So x to the power 4, that is 0 to the power 4 plus 2x cube, that means 2 into 0 to the power cube minus 0 minus 1, that is the giving us the result as minus 1, that is negative or less than 0. Once again we are just putting the value of x here as 1. The result of fx become plus 1, that means greater than 0, as the value of fx for 0 and 1 giving us opposite sign, that is minus 0 and plus 0. We are just finding the range of the first positive real root, and that is particularly 0 and 1. We must also can say that 0-1 range has the minimum positive real root. We are now proceeding with a table. This method is also known as the bisection method, whereas that is method of iteration. We are starting from the first iteration, where we are just considering an as 0 and bn as 1. That means the range lower value and 1 upper value of the range. As we have already found that at 0 the value of fx is equal to minus, that we are considering here, that is 0 and that is we are getting minus, and suppose that is the 1, we are getting the result as plus of fx. Just proceeding with the same thing, we have bisected the range. That is 0.5 we have got. That means 0 plus 1 by 2. So that means from that 0 to 1 we have just here completely bisected, and the result we found, that is 0.5. Now putting the value of 0.5 in the fx. Okay. Now we are getting the result as minus. That means f of 0.5 is minus. That means here we are getting minus. Now from 0 to 5, where 0 is for 0, value of x is equal to 0, we are getting the value of fx as minus, and for x 0.5, the fx, we are getting the result as minus. So simply we can eliminate that section, and we are proceeding in the same way as we have taken the range 0 and 1. That means opposite sign of fx, here 0.5 and 1, because for 0.5 the value of fx is equal to minus, and for 1 the value of fx is equal to plus. So we are proceeding to the second iteration. Now the range start from 0.5 and end at 1. In the same way, we have just bisected the range. That means 0.5 plus 1 by 2, and we have already got, that is 0.75. That means that must be here, that is 0.75. Now when we are checking the same thing, that means when we are putting the value of 0.75 for fx, we are getting the result as minus. So that means another, we are getting fx as minus. So again we are using the brackets, and for 0.5 that is minus, for 0.75 the fx is minus. We are just eliminating that range, and we are proceeding with the 0.75 to 1. So that is our third iteration. We are starting from 0.75 and that is 1. In the same way, just middle 0.875. Here we are getting the result of fx, that means f of 0.875, we are just getting, that is as plus the value of fx. So that means we are putting here the plus. Now check, that is plus, that is plus. So we are eliminating that range. So the range now from 0.75 to 0.875, and as usual that is our fourth iteration. Okay, in the same way we have already got, that is 0.8125. Now that is minus, giving the result of fx as minus. So simply once again we can eliminate that range. So the range becomes from 0.8125 to 0.875, and that is our fourth iteration. In the same way, if we proceed up to seventh iteration, we can get finally the middle point as 0.8732812. Particularly that iteration proceeds, but here as we have already got that is for the sixth iteration, that is 0.8671875, and for seventh iteration, that is 0.8632812. That means up to second decimal point we have already got, that is 86. So we can now say after the seventh iteration the root can be 0.86. As we are using that type of brackets also here, that is also known as bracketing method, and that is our bisection method or bracketing method or Bolzano method, which is used to find the root of any algebraic and transcendental equation. If you like the video, please share.